Before we start, I would like to thank you for purchasing this course. If you ever have any questions, please create a thread on the Q&A channel and I will make sure to answer all your questions as soon as possible. My name is Dimitris and in this course I will teach you the theory behind Linux privilege escalation and I will also cover real-life practical examples. Whether if you're studying for the OSCP exam or you're just trying to learn a new skill, this course is perfect for you. You will learn about Linux privilege escalation with file permissions, sudo bypass, cron jobs, passwords and keys, LXD, SUID and SGID, kernel exploits and NFS. We will cover each one of them in detail and make sure we first understand the theory before moving to the practical examples. After completing this course, you will go from beginner to advanced in Linux privilege escalation. If you already have an account on TryHackMe, feel free to skip to the next lecture. For those who don't know what TryHackMe is an online platform that teaches cybersecurity through short, gamified, real-world labs. We will be using their platform to practice what we learn on the course. To create an account, click on Join Now. You'll need to supply a username, an email address, and the password of your choice. I will call my account Test Hackademy, and the email address I'm going to use is testhackacademy@gmail.com, and I will also use a password of my choice. Click on I'm not a robot and sign up. Here you will be asked to select your experience level, so choose one and select continue. Then you'll get asked why you're learning cybersecurity, so just select one and continue. Now if you see this page, this means that you have successfully signed up on TryHackMe. And you can just choose a learning path. And now you're fully set up. You can go to the main page and you can view the dashboard. Don't forget to verify your email address. You should receive one, so go to your email address and verify your email. If you see this means that your account has been verified. Feel free to have a look around and to familiarize yourself with this platform. In the next lecture, I will show you how to join our own room in order to practice what we learn on this course. The next thing we need to do is to join the Linux privilege escalation TryHackMe room. This process is really simple. All we need to do is to open the link from the lecture resources. So I have copied and pasted the link from the resources of the lecture and I'm just gonna hit enter. Now if you see this page, it means that you have successfully joined the room. Here you can access all of the sections that will be covered in this course. Before we get started, you need to know that from this page you will be initiating virtual instances of vulnerable servers. These servers run on a virtual network on the cloud, and in order to access these machines, you need to connect to that network. Luckily for us, TryHackMe has made this really simple. To connect to the network, we need to first click Access Machines, then select OpenVPN, and here you'll see everything that you need to run. First, you'll need to download this file, which is the OpenVPN configuration file. Since I already have this file, I can click Cancel, but you should click Save File. Now the next thing we need to do is to run this command, which will download the OpenVPN application. So to do that, just open a terminal from the top left of your screen and paste down the command. Hit enter and you will be asked for the Kali password, which is Kali. Now it says here that the OpenVPN application is already installed on this machine, but if it's not installed in yours, you should wait for it to install and then you'll be able to use it. Now if you go back to the instructions, we can see that in order to use the OpenVPN file that we just downloaded, we need to run sudo openvpn and then specify the path to the file. So I'm going to copy this part of the command and paste it right here. Now I know that the path for the file that we just downloaded is home Kali downloads, and then you should see the file over here. So if I press tab, you should see the OpenVPN file. Keep in mind that yours will not be named test Hackademy. It will be named after the username of your TryHackMe account. So now that we have everything set up, we can just hit enter. And now if you see initialization sequence completed, it means that you have successfully connected to the TryHackMe OpenVPN network. We will see how to use this network in future lectures, but for now memorize this procedure because I will not be showing you guys over and over again how to connect to this OpenVPN network. In the previous lecture, we saw how we can connect to the TryHackMe OpenVPN network. In this lecture, we will dive deeper on why we are doing this and how we are doing this. So imagine that these machines over here are the machines that are connected to the TryHackMe network, and this is your machine that's connected to its own separate network. The green circle represents the TryHackMe network and the red circle represents your network. Now your machine cannot communicate in any sort of way with the machines on the TryHackMe network because these two have to be connected to the same network. So what we did in the previous lecture was connect to the OpenVPN network that the TryHackMe servers have. We did that so that our machine can communicate with these machines. So once we established a connection between the TryHackMe network and our own network, we were able to communicate with the machines on the TryHackMe side. If we hadn't done that, our machine would still not be able to communicate with the TryHackMe machines. In the next sections of the course, I'm not going to show you how to do that every time, so please memorize this procedure, and if you forget it, revise the previous lecture. In this section, we're going to talk about file permissions and how an attacker can take advantage of files that have incorrect permission sets. In Linux, file permissions, attributes, and ownership control the access level that the system processes and users have to files. This ensures that only authorized users and processes can access specific files and directories. The basic Linux permission model works by associating each system file with an owner and a group and assigning permission access rights for three different classes of users: the file owner, the group members, and others, which is everybody else. File ownership can be changed using the sound and chgrp commands. Three file permissions types apply to each class of users: the read permission, the write permission, and the execute permission. Here we can see an example of the ls-l command on a specific file. Now let's read the output of this command. We can see right here that these are the permissions of the file. The first character here should be the file type. The next three characters will be the owner permissions. In this case, the owner has read access and write access. The next three characters are for the group. And we can see here that the group has only read access. And the last three characters are for everybody else on the system, and we can see that everybody else has read access too. In other words, the owner of the file can read and modify the file, the group root can only read the file, and everybody else on the system can only read the file. Now let's say that this file contains credentials that are only to be seen by the owner of this file. The fact that everyone on the root group and everybody else on the system can read the file is not great. The owner of the file should change the permissions of the file and make it more private. Nobody should have read access except for the owner of the file. In the next lecture, we'll see how an attacker can take advantage of a file that has incorrect permission sets, and then he will become the root user. In the previous lecture, we talked about file permissions and how an attacker can take advantage of files that have insecure permissions. In this lecture, we will see how an attacker can gain root access through the etc password file. If you don't know what this file does, the etc password file is used to keep track of every registered user that has access to the Linux system. So head to the Hackademy Linux Privilege Escalation room and scroll down until you see the File Permissions section. Click on it and also click on Start Machine. We will need to wait for the machine to load in order to get its IP. Once we have the IP, we will make an SSH connection to the machine using the hacker username and the password 1234. Before we do anything, I would like to show you a quick trick. So click on the arrow over here and select the root terminal emulator. Type Kali and press enter. I will be using this terminal throughout the course because it allows me to open new tabs, split my screen and do many more things. And it comes with a benefit that the user that is running these commands from the terminal is the root user. Great, now that we have the IP address, we can SSH to the machine. I'm gonna copy the IP address of the machine. And on my terminal, I will run SSH hacker, which is the username that I want to use, and now add the IP address of the machine. I'm gonna hit enter, type yes and hit enter again, and now I need to supply the password. Like I said, the password is going to be 1234. Keep in mind that the machines from all the sections have the same username and the same password. So every time you're initiating a new instance, you can just copy the IP address and use the same username and password. And as you can see guys, we are now connected to the machine and we can start hacking it. Like I said, in this lecture, we're going to gain root access through the etc password file. Let's have a look at the permissions of the etc password file. To do that, we need to execute the ls-la command and then specify the path to our file, which is etc passwd. And don't forget the space here, and let's hit enter. In the previous lecture, we saw how we can identify the permissions of a file. With that information, we can see that the owner of the file has read-write access, the group has read access, and everyone else on the server has read-write access. This should not be happening. Only root should have the write access to the etc password file. And you will see why in a moment. Now that we know that we have write access on that file, we can elevate our privileges with a very simple procedure. We will first generate a password with the OpenSSL program using the command OpenSSL passwd and then specify our desired password. I will use the password 12345. Now we got this output, which we can use inside the etc password file. We will make this password hash the root password and then log in to root with the password that we just generated, which is 12345. So I'm going to copy the password hash that we just generated, and now I need to edit the etc password file. I will do that with the nano editor. Right where it has an X on root, we remove that and we add our own hashed password. We can now save the file and then try to log in as root. The command I'll be using is su root, and now I need to specify the password, which is 12345. And as you can see, we successfully elevated our privileges and we became the root user. Now we can just head to the root directory and view the contents of the root flag with the cat command. Now we can copy this flag, go back to tryhackme, and then paste the flag over here and submit. In the next lecture, we will see how we can do a similar thing with the etc shadow file. Okay, so now that we covered the etc password file, we can move to the etc shadow file. This file is a text file that contains information about the system's users' passwords. All of the hashed user passwords can be found inside that file. If we execute ls-la on the etc shadow file, we will see that we have read-write access to this file. This should also not be happening. only the root user should have access to read and write to this file. We will also see why in just a moment. We're going to follow a similar procedure. We will generate a hashed password and then replace it with the one that is already on the file. Before we do that though, we need to revert the changes that we just did to the etc password file. So replace the hashed password with the letter X. I'm gonna hit Ctrl X and save the file. Now we can go ahead and have a look at the contents of the file using the cat etc sudo command. As you can see, the root user has a hashed password. We can identify that this password is hashed with SHA-512 because of the $6. If you didn't know that, you could always use an online hash identifier to identify the hashing method that is being used on a string. Now that we know this information, we can go ahead and generate a hashed password that will use the SHA-512 encryption and then replace that with the current password. I will open a new tab on my terminal and use the command mkpasswd -m SHA-512 and then specify the password I want to use, which is test123. So what this command will do is create the password that I want using the SHA-512 encryption, and the key is going to be test123. And we can see the encrypted password. Now I'm going to copy this and replace it on the etc sudo file. So let's go back to the server and edit the etc sudo file with nano. We need to remove this password, so make sure you start deleting from this and until you see the end of the $6. Now we can paste our own password and now we can save the file. So hit Ctrl X, Y and enter. Now we can log in as root with the new credentials that I just created. So I'm going to run the same command su root and I'm going to supply the password test123. And as you can see, I once again became the root user. Now that we've seen these things, I believe you have a good idea of why it is important to use secure file permissions because of how easily exploitable some things can be. In this section, we're going to talk about sudo bypass. If a user that an attacker can access has permission to execute certain applications as the root user, can lead to a privilege escalation. So what is sudo bypass? The sudo configuration might allow a user to execute some command with another user's privileges without knowing the password. This can be achieved when a user is granted special permissions through the etc sudoers file. The attacker can run the command sudo-l. This command will list the binaries which the user can execute with sudo. After inspecting the programs in the command result, the user can visit a site called GTFO bins and look for ways to exploit the binary and elevate his privileges. GTFO bins collects legitimate functions of Unix binaries that can be abused to break out of restricted cells. So let's say that an attacker wants to check which commands he can use with sudo on a server with his current user. He will execute the sudo-l command and then he will be given a list with all the programs that he can use. There is a possibility that he cannot even execute this command because he does not have any sudo permissions. If he does however have sudo permissions, he can search them up on GTFO bins and then see whether if he can exploit them or not. In the next lecture, we'll see how we can do just that. In the previous lecture, we talked about how an attacker can check whether if he has special permissions on the system and how to exploit these special permissions. In this lecture, we're going to put the theory to practice. So head over to the Linux Privilege Escalation Try Hack Me room, scroll down until you see the sudo bypass section and click on it. And also click on Start Machine. Like I said in the previous section, we need to wait for the machine to load in order to get its IP, and once we have that IP, we can connect to it using SSH with the hacker username and the password 1234. Now that we have the IP, let's go ahead and connect to the machine. I'm going to copy the IP address of the machine, run SSH hacker and paste down the IP address of the machine. Let's hit enter on that. We can now say yes, and now we need to specify the password, which is 1234. Great, we are now connected to the target machine and we can start hacking it. Like I said in the previous lecture, in order to check whether if our user has special permissions, we need to execute the command sudo-l. As you can see, we have 3 programs on our command result. This is vim, nano, and find. We can run these commands as anyone on the system without supplying any password. This means that I can run these commands as any user on the system, including root, and I don't even need to know my password or the user's password that I'm running the command as. This of course is really not secure because of how easy it is to bypass sudo and get command execution with root privileges. Now let's try to become the root user. Like I said in the previous lecture, in order to find ways to execute commands with elevated privileges using the programs that we have been granted special permissions is to use the GTFO Bins website. Here you'll find ways to bypass local security restrictions in misconfigured systems. This project collects legitimate functions of Unix binaries that can be abused to break out of restricted cells, escalate or maintain elevated privileges, transfer files, and spawn, bind, or reverse cells. Feel free to browse the site and get familiar with all of the included binaries. If we go back to our sudo-l command result, we will see that the first program that we can run as sudo is vim. So let's search for it on GTFO bins. Click on the binary, and now you should see this page. Let's only focus on the cell function here. There are 4 ways we can exploit this. Let's try to execute option A. So let's copy this command and let's try to understand what it does. As you can see, we're executing the vim command, and then we're adding the C parameter. This parameter will execute any given command on the system as the user who is running vim. In this example, we are spawning an interactive system cell using main sh. Now if we add sudo at the start of this command, vim will be executed with root privileges. Therefore, the command that we also added to our vim command will also execute with root privileges. In the end, we will end up with an interactive system cell with root privileges. So let's execute the command and see what happens. We now have a new system cell, and if I run the id command, we can see that I am the root user. We can now head to the root directory and view the contents of the root flag with the cat command. Now that we have seen how we can bypass sudo using vim, try to do the same thing with nano and find on your own. In the next lecture, we'll see how we can elevate our privileges with the ld preload environment variable. Now that we have covered basic sudo bypass methods, let's move to something more advanced. Let's first exit from our root cell and run the sudo-l command again. To exit vim, type the following command and hit enter. Now let me clear my screen and I will run the sudo-l command again. So there is something really interesting in this output, and that is this line over here. We can see the ld preload environment variable being called by env-keep, which is essentially trying to load the shared library stored in ld preload. Don't worry if you don't get what I'm talking about just yet. Let's first explain what shared libraries are. In programming, a library is an assortment of pre-compiled pieces of code that can be reused in a program. Libraries simplify life for programmers. They provide reusable functions, routines, classes, data structures, and so on, which they can use in their programs. So functions like writing to a file, reading a file, and more can be added to shared libraries and loaded into programs so that the developer does not have to rewrite the same code over and over again. Now the LD preload environment variable is just loading these shared libraries, and with env-keep we are adding all of the default environment variables that are kept, and we are adding LD preload. This means that LD preload will not be overwritten when we make sudo calls. If we want a shared library to be executed before the selected program even boots, we can do that if we specify the path to the shared library with the LD preload environment variable. In order to exploit this, we need a user that has some form of sudo privilege, and our current user has just that. As we saw in the previous lecture, our user can run the programs vim, nano, and find as any user on the system without specifying any password. So what we are going to do in summary is create a malicious shared library, and then we're going to use this shared library with LD preload. Then when we go ahead and run a sudo command, we will be able to load our malicious shared library before our selected program even boots and get code execution as root. There is a pastebin link in the resources of this lecture that includes the script that we're going to use for this procedure. Since this is not a programming course, I will not go too deep on what it does. What you need to know is that we are first unsetting the LD preload environment variable, then we are setting our group ID as 0 and our user ID as 0, so we are essentially becoming the root user. And the last thing we're doing is spawning a system cell using bin.sh. Now let me copy this, cd to my tmp directory, and now I will create a file called cell.c with nano and paste down the script. So I'll do Ctrl X, say yes, and hit enter. So now we have saved the cell.c file and we have added our script. So since this will load before the program that we are going to call with sudo, we are just going to get this system cell instead of the actual program that we called. Now what we need to do with this file is compile it with the tool called gcc. Luckily for us, this machine has GCC pre-installed, so we don't need to compile it on our own Kali machine and then pass that to the server. And here is the command we need to execute. All you need to know about this command is that it will compile our C script and turn that into an SO file, which is a shared library file. So let me copy this and paste it on my terminal. Don't worry if you get these warnings, you can just ignore them. Now that we have that done, we can just run sudo specify ld preload equals tmp cell.so. Here we're just specifying the path to the shared library that we want to load with ld preload. And the last thing we need to do is add one of the programs that we have sudo access. I will use nano. So let's hit enter and you should get this system cell. Now if you run id, you should see that you are the root user, which means that you have successfully elevated your privileges using LD preload. In this section we're going to talk about cron jobs. So what are cron jobs? Cron jobs allow you to automate certain commands or scripts on your server to complete repetitive tasks automatically. This can be a very resourceful tool, as a cron job can be set to run by 15-minute or hourly increments, a day of the week or a month, or any combination of these. So let's say for example that you want to back up the contents of your web server's web root directory every week. You can set up a cron job for this case and it will automatically run every week. The attacker can run the command cat etc cron tab to view all the cron jobs that the admin has set up. It is possible that the admin has misconfigured the cron job and made it possible for an attacker to elevate his privileges. Maybe an executable file does not have the correct permission set, or maybe the cron job is running with a specified wildcard expression which can be exploited. Many things can go wrong. Don't worry about these examples for now, because in the next lectures of this section we're going to see how an attacker can exploit a misconfigured cron job. In the previous lecture, we talked about what cron jobs are and how an attacker can find these cron jobs and use them in order to elevate his privileges. In this lecture, we're going to put the theory to practice and try to become the root user using misconfigured cron jobs. So head over to our Linux privilege escalation room, scroll down until you see the cron job section and click on it, and also click on Start Machine. Now let's wait for the IP to show up so that we can connect to the server. Now that we have the IP, let's SSH to the machine using the hacker username and the password 1234. Say yes and specify the password 1234. And we're now connected to the machine. Like I said in the previous lecture, in order to enumerate the cron jobs on the target machine, we need to execute the command cat etc cron tab. So let's hit enter. And now we have the cron job configuration, and we can see that there are two cron jobs set. Both of them have the same schedule expression. So we can now head to a website called crontab.guru, and now we can add the schedule expression, which was 5 asterisks. And as you can see, this cron job will execute every minute. So again, what we did was get the schedule expression from this line and then paste it to this website to see how often this cron job is going to execute. The last thing we need to note here is that these shell scripts will be executed by the user root. So if we manage to exploit them, we will get a shell as the user root. In this lecture, we're going to focus only on the backup original file. We're going to use the backup new file in the next lectures. Notice how the file does not have a specified path. As you can see, we only have the name of the file. In order to inspect it, we need to search for the file, and to do that, we need to execute the command find, specify the path to our system, and then add the name, which is the backup original.sh. So what this command will do is search the whole file system for a file named backup original.sh. So let's hit enter and see what we get. We're going to get a lot of permission denied errors, but we're going to eventually get the file path. And as you can see, we found the file path, which is user local bin backup original.sh. So I'm going to copy this and stop the find command with Ctrl+C. Like I said in the previous lecture, a file that is said to be executed by a cron job can have misconfigured file permissions. We have already talked about file permissions in a previous section of the course. To check the file's permissions, we can execute the command ls-la and then specify the file path, so I'm just gonna paste that down. Here we can see that our user has read-write access to the file, right here, which means that we can view the contents of the file and also modify them. This is a major security flaw because every user on the system can do that, it's not just our user. So let's have a look at the file contents using the command cat followed by the path to the file. As you can see, this shell script is just executing a tar command, and it appears to be archiving the contents of the home hacker directory. Since we have write permissions to the file, we can modify it and add a reverse shell command, and because this file is executed by the user root, we will gain a root shell. So we can head over to the Pentest Monkey reverse shell cheat sheet which can be also found in the resources of this lecture. And now we can copy the bash reverse shell. Now let's run the command nano followed by the file path to edit the file. The first thing we need to do is to change the shebang on top and make it bin bash, because our bash script will not work with bin sh. So let me add bash here. So you should have a shebang that will look like this. Now we can comment out the tar command using a hashtag in front of the command, and now we can paste down our reverse shell command. We need to edit this command and add our Kali machine's IP and the port that we want to listen to. So here I will change the port to 4444, and now I need to get the IP address of the TAN0 interface from my Kali machine. So I will create a new tab, and now I'll need to run the ifconfig command. Like I said, we need the TAN0 interface IP because our target machine can only reach us through this one. So let's copy this, and now let's create a listener to capture the reverse shell. The command I'll be using is netcat-lvnp4444 because we're going to connect to this port from the target machine. So let's hit enter on that, and now we can head back to our target machine and paste down our Kali's IP. So I'll remove this IP and paste down the Kali IP. We can now exit and save the file with Ctrl X. We can now say yes and press enter. All we need to do now is wait for the cron job to execute. This shouldn't take long because it gets executed every minute, as we saw earlier through this page. And as you can see, guys, we got our reverse shell and we are the root user, as you can see over here. Now all that's left for us to do is to get to the root directory and get the contents of the root flag. In the next lecture, we will see how we can do a similar thing, but with the help of the cron job path environment variable. Now that we have covered privilege escalation with misconfigured file permissions from cron jobs, we can move to the path environment variable. But what is the path environment variable? First of all, here is the path environment variable. As you can see, there are multiple paths inside this variable. So when a cron job does not have an absolute path, just like this one, it will look for the specified file on all of the paths in order. So it will check on the first one. If it doesn't find it, it will move to the next one, and it will do that until it finds the file. As you can see, our user's home directory is the first on the list. This directory is also writable for our current user. Because the file on the cron job does not have a specified path, we can create a malicious file on our home directory and give it the same name as the one we saw on the cron job. This will make the cron job execute the file saved on our home directory and not the legitimate file that is stored somewhere else. So if you're not in your user's home directory, you can do that using cd. And now we need to create a file named backup_original.sh. It has to be the same name as the one on the cron job. Otherwise, it will never be executed. I will be using nano to create and edit the file. So the command I'll be using is nano backup_original.sh. So write this script down with me and we will explain what it does. So the first line just adds the shebang. With the shebang, we're specifying the bin bash program to be executed, followed by the path of our shell script. The next line copies the bin bash binary and pastes it down to the tmp directory and gives it a name root bash. The final line gives the file SUID permissions and execute permissions. We will talk about SUID in future lectures, but what you need to know right now is that a file with SUID permissions allows the user who executes it to run the file as the owner of the file. And because bin bash is owned by root, when we execute the root bash binary, we will get a root shell. So we can now save the file with Ctrl X, say yes and press enter. Now if we do ls, we can see the backup original file over here. Now we need to make this file an executable. So to do that, we need to give it the permission chmod +x and specify the name of the file, which is backup original.sh. Now if we do ls again, we will see that the file is green, which means that it is an executable, and we can also confirm that with the ls-la command. As you can see, we have execute permissions over here. Now we can wait for the cron job to run. This shouldn't take long because it is set to run every minute. Now we can have a look at the tmp directory using the ls command and then specify tmp. And as you can see, we have the root bash binary over here. To execute it, we need to run the command tmp root bash, and now we need to add the p parameter, which will execute the file as the user who owns it. And like we said before, this file is owned by root. So if I enter here and do id, we can see that I have root permissions. So essentially, we now have a bash session with root permissions. The last thing we're going to have a look at in this chapter are wildcards on cron jobs. As you can see, there is another cron job running every minute by the user root. Now let's see the contents of this shell script. We know from a previous lecture that these files are stored in the user local bin directory. So the command I'll be using to inspect the contents of the file is cat followed by the path to the file, which is user local bin, and now I need to specify the file, which is backupnew.sh. We can now see the contents of the shell script. As you can see, we are running a tar command just like the other cron job, but this command has a specified wildcard. The wildcard will expand to include the files in the current directory on the tar command. Let's see a non-malicious example of how we can exploit this. So I will clear my screen, and now I will create a file called test with the echo command, and I will write to it hello world. And like I said, I'm going to save this to a file called test. So with this command, we're creating the file test, and inside the test, we're placing hello world. So I'm going to hit enter, and now I will create a second file called --help. I'll do the same thing. I'll run the echo command. I will write to this file hello world 2, and I will save that to a file called --help. So I will hit enter on that. Now to view the contents of the file, I'll need to use the cat command followed by the name of the file. So let's first test the test file. So I'm going to run cat test. As you can see, we get the contents of the file, which were hello world. Now let's try the same thing with the file named --help. So the command I'll be using is cat --help. Now instead of showing us hello world 2 while opening the file, it calls the --help option and shows us the help menu. This is called wildcard wildness. Since the file name is a valid cat command line option, cat will treat it as a command line option rather than a file name. What we want to do is a wildcard injection. Basically, with the help of a wildcard injection, an attacker wants to gain the highest privilege on the system. Therefore, he will try to inject some malicious code with the help of the tar command. But there are multiple ways to obtain root access by exploiting this vulnerability. Let's see how we can do one of them. Make sure that you are on your user's home directory. So if you see this it means that you are in your user's home directory. To get to your user's home directory, you can just execute the cd command and you will be there. So I'm going to clear my screen once again. And now I need to create and store my malicious files here. Now execute the following commands with me and I will explain what each command does. Now that we execute the commands, I can explain to you what each command does. In the first command, we are creating a shell script called demo.sh. The contents of this file contains another echo command that will add our user to the etc sudoers file, and it will let us run commands as the root user without specifying any password, as you can see over here. So our user, which is hacker, will get root access and he will not need to specify any password while running sudo commands. And this line over here will be passed inside the etc sudoers file. The next command executes an action at each checkpoint. In our case, it is executing the shell script. So right here, we're setting a checkpoint action for the tar command, and we're saying that we want to execute this command over here. So essentially, we're executing this shell script that we just created. The next command shows the progress messages every one record. And the last command is making the demo.sh file an executable. So we're giving the demo.sh file execute permissions. Now keep in mind that these file names will be treated as tar command line options. So this means that after the 1 minute has passed, tar should find these options and inject them to the command. This should give us root permissions, so let's wait for it. Alright, now that a minute has passed, we can execute the sudo-l command to view our user's permissions. So I'll do just that. I'll run sudo-l, and as you can see, I can run everything as the root user without specifying any password, just like I wanted it. The last thing I need to do is to become the root user. To do that, I can just execute the sudo-su command, and I am now the root user. In this section of the course, we are going to have a look at the passwords on files. We're going to see how passwords can be easily found inside history files and configuration files. These are less likely to happen in a real-life scenario, but could be found on a capture the flag competition. So head over to our Linux privilege escalation room, scroll down until you see the passwords on files section, click on it and also click on start machine. Now let's wait for the IP to show up. Now that we have the IP, we can copy it and now SSH to the machine using the hacker username and the password 1234. We can say yes and now specify 1234, and we are now connected to the machine. In this lecture, we will only have a look at command history files. But what is a history file? A history file contains the last commands that a user has recently used. So any command that I type is added to this history file. To view the contents of the history file, we need to execute the command cat specify our user's home directory, and now say we want the .history file. The dot on the history file name indicates that this file is hidden, so any file and directory with the dot in front of the file name means that it is a hidden file. So we can now enter, and we can now see all of the commands that our user previously executed. We know how humans can make mistakes that at the time seem minor but then become a big problem. As you can see in the command result, the user has executed a command and he has accidentally revealed the root password. He added the U and the P parameters, but he forgot to add spaces on the command. So now we know that the root password for MySQL is ultrapassword. Now let's see if we can use the password to become the root user. The command I'll be executing is su root, and now it asks me for a password. I will now specify ultra password. You will not be able to see what you're typing, so make sure you don't make any mistakes. And now I'm gonna hit enter. And as you can see, we successfully elevated our privileges and we became the root user. We can now move to the root directory and view the contents of the root flag. In the next lecture, we will have a look at the configuration files. Now that we have seen how we can get passwords from the Linux history file, we can move to the configuration files. Make sure you are on your user's home directory. If you are not, then execute the cd command and it will bring you here. If you list the contents of the home directory with the ls command, you will see a directory called VPN files. Now let's cd into that directory to see what it has inside. Again, I will execute the ls command to view the contents of the VPN files directory. And as you can see, we have a file called hackervpn.ovpn. The ovpn extension indicates that this file is an OpenVPN file. This file is just like the one we use to connect to the TryHackMe OpenVPN network. Let's view the contents of the file with the cat command. Now through this line we can see that in order to authenticate, it gets the credentials from this path. This means that if the file does not have the correct permissions, we could view the contents of the file and get the credentials. We can do that using the cat command, and once again we will need to specify the path to the file. And as you can see, we got the username root and the password ultra password. If the admin added secure permissions to the auth.txt file, I wouldn't be able to view the username and the password of the user. In this section, we're going to talk about LXD. So what is LXD? LXD is a next-generation system container and virtual machine manager. It offers a unified user experience around full Linux systems running inside containers or virtual machines. LXD is image-based and provides images for a wide number of Linux distributions. The Linux containers, or LXC, are often considered as a lightweight virtualization technology that is something in the middle between a chroot and a completely developed virtual machine, which creates an environment as close as possible to a Linux installation but without the need for a separate kernel. A Linux daemon, or else LXD, is a lightweight container hypervisor. LXD is building on top of the LXC container technology, which was used by Docker before. It uses the stable LXC API to do all the container management behind the scene, adding the REST API on top and providing a much simpler, more consistent user experience. A member of the local LXD group can instantly escalate the privileges to root on the host operating system. This is irrespective of whether that user has been granted sudo rights and does not require them to enter their password. The vulnerability exists even with the LXD snap package. LXD is a root process that carries out actions for anyone with write access to the LXD Unix socket. It often does not attempt to match the privileges of the calling user. There are multiple methods to exploit this. One of them is to use the LXD API to mount the host's root file system into a container. This gives a low privilege user root access to the host file system. In the next lecture, we'll see how we can do just that. In the previous lecture, we talked about what LXD is and how an attacker can use it to escalate his privileges. In this lecture, we're going to put the theory to practice. So head over to our Linux privilege escalation room, scroll down until you see the LXD section and click on it, and also click on Start Machine. Now let's wait for the IP to show up. Now that we have the IP, we can copy it and we can now SSH to the machine using the hacker username and the password 1234. We can now say yes and add the password, which is 1234. And we are now connected to the machine. Now, like I said in the previous lecture, I need to check whether if my user is part of the LXD group. To do that, I can run the groups command. And as you can see, my user is part of the LXD group. This indicates that I might be able to gain root access through LXD. Now, what we're going to do is create a container using LXD, and we are going to mount our system's root directory onto a directory on the container. Then we will access the container with a privileged user, and we are going to gain access to any files or directories inside the root file system. Let's see how we can do that. Since the target server is not connected to the internet, we will need to build the container that we are going to use for this attack on our Kali machine and then transfer that to the target server. For this lecture, we're going to use this tool, which is called LXD Alpine Linux Image Builder. This tool will create the container image that we are going to import to LXD on our target server. So we can now go ahead and clone this GitHub repository. So I will copy the Git address from here. I'll go to my terminal and create a new tab. And now the command I'll be using is git clone, and now I need to paste down the address that I just copied. So I will hit enter on that. And perfect, we just cloned this GitHub repository. Now that this is done, I can cd into the directory called LXD Alpine Image Builder. And now I need to run the script that will build my Alpine image. As you can see from the documentation in the GitHub repository, we can see that we need to run this command. So let me execute this. And now let's just give it some time to run. Great, we now have our image built. If we execute the ls command to list the contents in our current directory, we can see it right here. Like I said, we now have to transfer this image to our target server. Since my Kali machine and the target server are communicating, the easiest way to do that is to start a web server service on my Kali machine and set my current directory as the web root so that we can access and download the file from the target server. The command I'll be using is python 3-m http server on port 80. What this command does is call Python, then with the m parameter we're executing the HTTP server module, and we are telling it to run on the default HTTP port, which is port 80. This will create a web server on my current directory and will allow me to access the Alpine image from the target server. So I now need to hit enter, and we can see that it started serving HTTP on all of the interfaces on port 80. Now let's head back to the target server and see how we can download the file. Let's first move to the TMP directory. And now to download the file, we need to execute the command wget specify HTTP. And now we need to add our Kali's IP address, which we can find using the ifconfig command. So I will split my screen here and execute the ifconfig command. We need the IP from the TAN0 interface, which is created when we connect to the TryHackMe OpenVPN network. So I'm going to copy this and paste it down on my command. And the last thing we need to add is the name of the file that we are trying to access. To do that, I can go back to this terminal and copy the name of the file that I want to download. And now I can paste it down. Now let's hit enter and the file should download. And as you can see, the file was saved. Now that we have that done, We can now initialize LXD on the target server with the command LXD init. It will ask us a bunch of questions to which we can just hit enter, and once we are done with this, LXD will be initiated. Now let's import the image that we just built to LXD. The command I'll be using is lxc image import, and now we need to specify the name of the file, which was Alpine, and we can just hit enter to autofill the name of the file. And the last thing I will add to this command is an alias with the -- alias option, and I will call this image root. We can now hit enter. Now to confirm that the image was indeed imported, we can run the lxc image list to view all of the images, and as you can see, we have our image right here. Now what we want to do is to create a container using the imported Alpine image. To do that, I need to execute the command lxc init root. Root is the name of the image that we previously imported, and now I need to specify a name for the container, so I will call it root container. And I will also add the C option and set security privileged equals true. Basically, we are doing this so that the root user on the container also has root access to the local file system. And I can just hit enter. It looks like I made a typo. It's not privileges, it's privileged. So I can hit enter again, and it says creating root container. Now if we run the lxc list command, we can see the container that we just created, but it is offline. The next thing we need to do is to mount the root directory onto the container file system in a disk type so that we can access the contents of the root directory from within the container itself. To do that, we need to execute the command lxc config device add, then specify the name of our container, which is root container. Call the device my device. Set the device type to disk. And now we need to specify the source with source equals root. Then add the path that we want to mount the source, which can be added with the path equals mnt root. So the root directory on our current file system will be found in the mnt root directory on the container. And the last thing is to add the recursive option and set it to true to make sure that we get all of the files and directories within the source directory. In our case, the source directory is the root directory. We can now hit enter, and it says device my device added to root container. Now that the device is added, we can go ahead and start the container with the command lxc start root container. To access the container and gain an interactive cell session with it, we need to execute the command lxc exec, then add the name of the container, which is root container, and we need to specify bin sh for the cell type. Now if we run id, we can see that we are the root user, but not on the whole system. We are root just on the container. We can now cd into the directory where we mounted the file system's root directory with the command cd mnt root. And now if I run ls, we will see the contents of our system's root directory. The last thing we want to do is to view the contents of the root flag with the cat command. Now keep in mind that with this method, we only have access to the root directory of our system. If we wanted to keep our root access, we should have mounted the whole file system, and then we could have edited the hacker user permissions. We could have also created a new root-like user, and many more things. If you want to test what you learned so far, try to mount the whole file system and gain full root access on the target machine. In this section, we're going to talk about NFS. What is NFS? The network file system is a protocol that allows users to access files over a computer network, much like local storage is accessed. Like many other protocols, it builds on the Open Network Computing Remote Procedure Call, the ONC RPC system. If misconfigured, it could allow regular users to escalate privileges to root. Once an attacker gains access to the target server that is running a misconfigured NFS service, he will be able to escalate his privileges by exploiting the vulnerable NFS source. He can view the service configuration using the cat etc exports command. In order to exploit the vulnerable NFS SER, a binary has to be placed on it so that the SUID permission can be assigned to it from the attacker machine. In the next lectures on this section, we're going to see how we can do just that. In the previous lecture, we talked about NFS and how an attacker can enumerate its configuration. In this lecture, we're going to put the theory to practice. We will enumerate the NFS configuration and the NFS source, and in the next lecture, we will try to exploit the vulnerable source. So head over to our Linux privilege escalation room, scroll down until you see the NFS section and click on it, and also click on Start Machine. Now let's wait for the IP to show up. Great, now that we have the IP, let's SSH to the machine using the hacker username and the password 1234. And we are now connected to the machine. Now I will open a new tab on a terminal and I will use a tool called Nmap to scan the open ports and services running on the target machine. If you're not familiar with Nmap, Nmap is one of the core tools used by network administrators to map their networks. The program can be used to find live hosts on a network, perform port scanning, ping sweeps, OS detection and version detection. So the command I'll be using is nmap-sv-a and then specify the IP of my target machine, which is this one. -sv will probe all of the open ports and -a will enable OS detection. So let's hit enter on that and let's wait for this to end. Now that it is done, we can scroll down and see all of the open ports and services running on the server. We can also see the NFS service running, which indicates that there might be some NFS sers that we might be able to enumerate. We can now run the so-mount-e command and then specify the IP address of our target machine. The so-mount utility shows mount information about an NFS server, and the e parameter will show the NFS server export list. So with this command we should get the NFS sers. So let's hit enter on this, and as you can see we have one NFS ser which is stored under mnt shared folder. Going back to the server, we can run the cat etc exports command to view the NFS configuration. We talked about this command in the previous lecture. This right here is the configuration. At the bottom of this result, we can see our NFS ser. What is interesting about this configuration is that no root squash is specified. When this setting is set, it will allow remote root users that have mounted this ser in their local system to change any file on it as root and leave malicious applications for other users to execute. This can be exploited by copying a binary to the ser, making it root-owned and assigning SUID permissions to it, so the regular users will be able to run it as root. Don't worry about what SUID is right now, we will cover this in a future section of this course. Now that we have enumerated the NFS configuration and the NFS sers, in the next lecture we will see how we can exploit this vulnerability to gain root access. Now that we found and identified the vulnerable NFS ser, it is time to exploit it. Like I said in the previous lecture, what I need to do is copy a binary to the ser, make it root-owned and assign it SUID permissions. SUID will be covered in future lectures, but what you need to know right now is that files with SUID can be executed as the user who owns them. In our case, this will be the root user. So let's get started. The first thing I need to do is to navigate to the ser directory, which was mnt serd folder, and I need to copy and paste the bin bash binary. With this command, I'm copying the bin bash binary and I am pasting it down on my current directory. The next thing I need to do is create a serd directory on my Kali machine, which I will use to mount the NFS ser onto it. So going back to my Kali machine, I can now run the mkdir tmp serd command, which will create a serd directory on my tmp directory. Now I need to mount the NFS ser onto the directory that I just created, and to do that I will use the following command. Don't worry about this command and what it does. All you need to know is that we're executing the mount program, we're adding our options, and we're also adding the target's file system type, which in our case is NFS, and finally we're adding the target's IP address followed by its ser and the directory that we want to mount. So over here I will change this and copy the IP address of my target machine again and paste it right here. I'm going to say that the ser is located under mnt serd folder, and the directory that I want to mount is tmp serd. So let's hit enter on that. And now if we cd into tmp serd and now run ls to list the files in the current directory, we can see the bash binary that we previously copied and pasted onto the ser from the target server. Since the ser was mounted locally with the no root squash option enabled, we can change the permissions and ownership of the binary and make it root-owned and assign SUID permissions to it. To do that, we need to execute the command shawn root.root and specify the name of the file, which is bash. This command will change the ownership of the file and make it the root user. And also we need to run chmod +s and specify the name of the file, which is bash. This command will give the file SUID permissions. So let's also hit enter on that. And now we can head back to the target server and run ls-la on bash. And we can see that it is now owned by root and that it has SUID permissions. All that's left for us to do is to run bash and add the p parameter, which will execute the binary as the user who owns the file. In our case, this is the root user. So I'm gonna execute bash and specify the p parameter, and now I get a new bash session. Now we can run the id command, and as you can see, we are the root user. We can now head to the root directory and get the contents of the root flag. In this section, we're going to talk about kernel exploits. What are kernel exploits? Kernel level exploits exist for a variety of Linux kernel versions. A very well-known example is the Dirty Cow exploit. These leverage vulnerabilities in the kernel to execute code with root privileges. It is very common to find systems that are vulnerable to kernel exploits. It can be hard to keep track of legacy systems, and they may be excluded from patching due to compatibility issues with certain services or applications. Privilege escalation using a kernel exploit can be as simple as downloading, compiling, and running it. Some of these exploits work out of the box, while others require modification. A quick way to identify exploits is to execute the command uname-a and search on Google for the kernel version. In the next lectures of this section, we're going to see how we can do just that. In the previous lecture, we talked about what kernel exploits are and how an attacker can use them to elevate his privileges. In this lecture, we are going to use our TryHackMe room to find and exploit a vulnerable kernel. So head over to the TryHackMe Linux Privilege Escalation room and scroll down until you see kernel exploits. Click on it and also click on Start Machine. As always, we're going to use the username hacker and the password 1234 to SSH to the machine. So wait until the machine loads to get its IP address. Great, now that we have the IP address of the machine, we can copy that. We can go to our terminal and SSH to it. We're going to use the hacker username and we need to paste down the IP address of the machine. Hit enter on that and say yes. Now it's asking for the password, and as always we're going to use the password 1234. Great, so now we are inside the machine. Our goal here is to find the kernel exploit that we can run on this server to get the root access. Like I said in the previous lecture, we can use a command that will show us the kernel version running on our current machine. That command is uname-a. As you can see, we get a lot of information about our current system, but the only thing that we are interested in is this right here. This is the kernel version. Now we can go ahead and copy and paste that on our browser to manually search and find exploits that can be used on this kernel. But that is not ideal. There is a much simpler way of finding exploits for kernels, and that is using a tool called Linux Exploit Suggester. This tool will get our kernel version and it will search through its database to see whether if the kernel that we currently have is vulnerable to any exploits. Once it is done doing that, we will get an output of all of the possible exploits that we can use on this server. Since the TryHackMe machines don't have internet access, what we need to do is download this tool on our Kali machine and then pass the file to the server. So let's do just that. I'm going to copy the wget command from the GitHub repository and I'm going to run this on my Kali machine. The next thing I need to do is run a Python HTTP server on port 80 so that the server can get the file through a web request. The command I'll be using is python 3-m http server, and I'm going to run the HTTP server on port 80. So let's hit enter on that, and as you can see it says that it's serving HTTP on port 80. Now I will split my screen and get the IP of my machine from the Tanzero interface, and the IP is this one. So I'm going to copy that, go back to the server, and now I can download the file from my Kali machine. I will first change the directory and go to the TMP directory, and here I'm going to wget the file from my Kali machine. This is the IP address of my Kali machine from the TAN0 interface, and the name of the file is les.sh. So I'm going to hit enter on that, and it says that les.sh has been saved. If I do ls, we can confirm that les.sh is indeed saved. So I will clear my screen here, and now I need to change the permissions of the les.sh file and make it an executable. To do that, I'm going to run the chmod +x command and specify the name of the file. Now if I do ls again, we can see that the file now has green colors, and if we do ls-la, we can see that the file has execute permissions. Now all that's left for us to do is to run the file. As you can see, there are a lot of exploits that we can use, but the one we're looking for is the Dirty Cow exploit. Here is the official page for the Dirty Cow exploit. If you're not familiar with the Dirty Cow exploit, Dirty Cow, or else known as Dirty Copy on Write, is a computer security vulnerability for the Linux kernel that affected old Linux-based operating systems, including Android devices that used older versions of the Linux kernel created before 2018. It is a local privilege escalation bug that exploits a race condition in the implementation of the copy on write mechanism in the kernel's memory management subsystem. Computers and devices that still use the older kernels remain vulnerable. All kernel versions before 4.8.3 are vulnerable to this exploit. And as you can see, if we run uname-a again, the kernel version on this server is 3.13.0, which is vulnerable to Dirty Cow. So let's view all of the exploits, and the one we're looking for is cowroot.c. As you can see, the developer has left us a comment on how we are supposed to run this exploit, and over here it says that we need to compile the exploit and then execute it. Running kernel exploits is as easy as downloading them, compiling them, and then executing them. Now this exploit requires GCC to be installed on the server in order to compile the exploit. But if we run with GCC on the server, we can see that GCC is not installed. Now if I do the same thing on my Kali machine, let me stop the HTTP server and run with GCC, we can see that GCC is installed. So what I will do is get this file to my Kali machine, compile it on my Kali machine, and then pass that file to the server, just like we did with the les.sh file. I will now click on the raw version of this, copy the URL, and run the wget command on this URL. Now cowroot has been saved. To compile the exploit, we need to run this command, so I'm going to copy it from the comments of this exploit and paste it on my terminal. We can ignore these warnings, and now it says that we just need to run this. So again, I'm going to run the Python HTTP server on port 80, and I'll go back to my server on Hackademy, and this time I'm going to download the cowroot exploit. I will search for the wget command that I executed earlier, and here it is. Now instead of downloading les.sh, I want to download cowroot. So let's hit enter on that, and it says that cowroot has been saved. If I do ls, we can see the cowroot executable over here. We also need to run the chmod command again in order to change the permissions of the file and make it an executable. And now we can run the exploit. And as you can see, I have the root access. If I do ID, I am the root user. So we have successfully elevated our privileges and we became the root user. The last thing I need to do is go to the root directory and get the contents of the root flag.txt, paste them on the answer over here and submit it to Hackademy. In this section, we're going to talk about SUID and SGID. So what are SUID and SGID? The set user ID is a type of permission that allows users to execute a file with the permissions of a specified user. Those files which have SUID permissions run with higher privileges. Assume we are accessing the target system as a non-root user, and we found SUID bit enabled binaries, then those binaries can run with root privileges. The attacker can use the following command to find SUID files. We will talk about this command more in future lectures. In Linux, some of the existing binaries and commands can be used by non-root users to escalate root access privileges if the SUID bit is enabled. There are some famous Linux Unix executable commands that can allow privilege escalation. These are bash, cat, cp, echo, find, and more. The attacker can also search for more ways to exploit the SUID permission on a binary using a website called GTFO bins. Now that we have covered what SUID and SGID is, it is time to put the theory to practice. So head over to our Linux privilege escalation room, scroll down until you see the SUID and SGID section and click on it, and also click on Start Machine. Let's wait for the IP to show up. Great, now that we have the IP, let's SSH the machine using the hacker username and the password 1234. And we are now connected to the machine. Now what we want to do is try to find the SUID files in this machine. Like I said in the previous lecture, to do this we can execute this command. This command will search in the whole file system for SUID files. Now let's execute it and see what we get. As you can see, we have a lot of results, but most of these are normal. Some binaries need to have the SUID permission. One of the binaries that is not supposed to be in this list is nano. Since there is no actual list for the default SUID binaries for each Linux distribution, you will need to identify the one that does not fit with the others on your own. Now that we know which binary is not supposed to be in this list, in the next lecture we will see how we can gain root access with SUID on nano. Now let's try to get root access by exploiting the SUID permission on the file. Because binaries with the SUID permission can be executed as the user who owns the file, we can try to see whether if root owns this file and then find a way to get a root cell. Now let's run the ls-la command on bin nano to check the permissions of the file and the owner who owns the file. To check the permissions of the file and the user who owns the file. As you can see, it is owned by root, so that means that we can try to edit some files that our user cannot with his privileges. Let's take for example the etc sudoers file. Through this file we can assign our user root permissions if we were able to edit it. We have already done this in a previous lecture. Through this file we can assign our user root permissions if we are able to edit it. If we run ls-la on etc sudoers, you will see that our user does not have access to this file. What we can do to bypass this is to edit the file with nano, and because it will execute with the root privileges, we will be able to see and modify the contents of the file. So the command we're going to use is bin nano and then specify etc sudoers. As you can see, we're able to view the contents of the file. Normally, we wouldn't have read access to the file. What we need to do now is to add our users into the etc sudoers file and copy the root user's configuration. So what I'm going to do is go right under root, specify my user's username, which is hacker, and then I will copy and paste the root user configuration. Now that we have that done, we can save and exit the file using Ctrl X, say yes, and press enter. Now if I run the sudo-l command to view my user's permissions, we will see that I am able to run everything as anyone on the system. I need to supply my password, which I know that is 1234. And like I said, we're able to run everything as anyone, so we basically have root access. This means that I can just run sudo -. This means that I can just run sudo su, and now I am the root user. The last thing I need to do is to head to the root directory and view the contents of the root flag. In this course, we have been mostly finding and exploiting vulnerabilities manually, but there is a much simpler and quicker way of finding and exploiting them. The reason I structured the course like this is so that you can learn how things work and how hacking tools approach the systems to find vulnerabilities. In this section of the course, we're going to have a look at what I personally believe are the best and only tools that you will need while trying to privilege escalate. In the next lecture, we will have a look at a tool called linpiz. In this lecture, we're going to have a look at what I believe is the best privilege escalation tool. That tool is called linpiz. Linpiz is a well-known enumeration script that tries to find possible ways to privilege escalate on a Linux system. It searches for things like bad file permissions, sudo bypass vulnerabilities, misconfigured cron jobs, and basically everything showed in this course. Now let's see how we can use this tool and how we can automatically find vulnerabilities on the system. For this section of the course, I will be using the machine found on the sudo bypass section on our Linux privilege escalation room. Now head over to this GitHub repository, which can be found in the resources of this lecture. We will need to get this linpiz file on the target server. Like I said previously in another lecture, the target machines on TryHackMe do not have internet connection. We will need to download the file on our Kali machine and then pass the file to the target server. To do that, click on the linpiz.sh file and also click on raw, and now copy the address from your browser's address bar. Now head back to the terminal and create a new tab and execute the command wget and then paste down the address that you just copied. This command will get the contents of this page and it will put it inside a file called linpiz.sh. Now that we have successfully downloaded the script, we can move to the next step, which is getting the file to the target server. I will need to start a web server and set my current directory as the web root directory. The web root directory is the one where all the website related files are stored and can be accessed by clients. So the linpiz.sh file will be inside that web root directory, and since the target machine and my Kali machine can communicate through their own network with HTTP requests, I will be able to see and download the file into the target server. The command I'll be using is python3 -m http server on port 80. What this command does is call Python, and with the m parameter we are executing the http.server module, and we are telling it to run on the default HTTP port, which is port 80. Now let's execute this and let's head back to the target server, and we can now download the file. The command I'll need to execute is wget, specify HTTP, and now we need to add our Kali's IP address, which can be found using the ifconfig command. I will split my screen here and execute the ifconfig command. We need the IP from the tan0 interface, which is created when we connect to the TryHackMe OpenVPN network. We can copy and paste it on our command, And the last thing we need to add is the name of the file that we are trying to access, which is linpiece.sh. So this command will download the file from our Kali machine. We can execute the command, and as you can see, we have a GET request that came from our machine, and if we do ls, we will find the linpiece.sh file on our current directory. Now that we downloaded the file, we can execute it. Make sure you change its permissions and make it an executable with the command chmod +x and then specify the name of the file. And now we're good to go. All we need to do is to run the command linpiece.sh. Let's hit enter and we will go through the result together to understand the command result better. Linpiece colors the things that it finds, and each color means something different. For example, if you see red and yellow on the result, it means that it might have found a privilege escalation vulnerability. Red means that you should have a look at something a bit more. Light cyan means users with console, blue users without console, green it means common things, and light magenta is your username. Now let's wait until we see red and yellow. As you can see, this tool also runs the Linux exploits adjuster. We use this tool in the kernel exploit section. Here it shows us all the available cron jobs, so if we were to run this in the cron job section machine, we would see our cron job show up over here. And as you can see in the users information section, we can see that it flags the environment keep variable as a potential privilege escalation vulnerability, and also flags the fact that our user can execute the commands vim, nano and find as anyone on the system without specifying any password. These are exactly the things that we found during our manual exploitation. Now you can go through the whole result and search for red and yellow flags or just red flags on any system. Since this tool outputs a lot of information that most of the time is not needed, we won't be going over everything. Just follow the same principles while using this tool and be on the lookout for vulnerability flags. This script requires Python to be installed on the system in order to use it. To check whether if Python is installed, we can use the command which python. If it is installed, we will get the path to it, but if it's not, then we will not get anything. As you can see, Python is not installed. But there are two versions of Python. There is Python version 2 and Python version 3. We can also execute the command which python 3, which will search specifically for Python version 3, and as you can see, Python 3 is installed on the system. Now to execute the script, we need to run the command python 3 and then specify the name of the file, which is gtfo.now.py. So it asks us for the sudo password, and we know that our user's password is 1234, so I'm going to type that out. You will not see it on the terminal, so make sure you don't make any mistakes. And now if you don't know the password, you can just leave this blank and just press enter. Now it will show us all of the programs that we should be able to use to privilege escalate. After that, it will show us all the SUID binaries, and the last thing are going to be the SGID binaries. Now it will ask us whether if we want to exploit a pseudo binary or exit. I will type 0 to select it and press enter, and now it will show us the available payloads. I will use the first one, which can be selected by typing 0. So I will hit enter. Now it says that it is spawning a root cell, and if I execute the command who am I actually made a mistake. The command is who am I. We can see now that I became the root user without doing anything. All I did was execute the tool, and it automatically found all of the possible binaries that can be used to privilege escalate. Remember, we did the same thing when we did that manually. We found the binaries through the sudo -l command, and then we went to GTFO bins and looked at the binaries and found ways to exploit them.